Welcome to Sanford Flip Math, the home edition. We are coming to you live. Okay, well, it's not live anymore because you're looking at a recording from my kitchen. Who knew? So we're laying down some videos to basically talk about right now law of sines, law of cosines, all that kind of stuff. And this is the intro video for law of sines. This is the where does it come from and why do we use it, and then a couple examples. So we're going to try and keep this moving. Obviously, as you're watching this back, you can watch this back at whatever rate you want. You can pause it or whatever. All right, so here we go. We're going to start out by with just a basic triangle, not a right triangle, any kind of triangle, and we're going to set up the area of this triangle. Now, part of the problem with is, I'm sure you're very comfy with the idea of area is 1/2 base times height. Well, the problem is that, okay, I can use this as a base, but what's the height? And the height has to be perpendicular to the base. So I can use 1/2 base times, but what do I use for height? Okay, so what we're going to do is set up a little guy. We're going to call this H, and this angle is opposite H, and worth noting that as I make that perpendicular, this is now a little baby right triangle. Okay, so we're going to think about just that little right triangle for a second. I don't know this length because the B is the whole thing, but I do know that length. So I'm going to call that A. I'm going to call that angle C, and this is H. And so to find H, that's opposite, that's hypotenuse. So the sine of angle C is equal to opposite over hypotenuse for that little guy. And then height, if I multiply by A, is A times C, or A times sine of C rather, sorry. Now, I'm going to rewrite that in a little bit different order. So 1/2 AB sine of C. And this actually becomes a nice alternate formula for the area of a triangle. This works anytime you know a side, and an angle. So if you have what we call in geometry an SAS arrangement, you don't know the base and the height necessarily, but you know two sides and the included angle, then that gets you the area of the triangle. Okay, this works for any triangle if you know those two sides and the angle between them. Okay, now there's nothing magical about those two sides and that angle between them. So I could have 1/2 AB sine of C, which happens to be equal to, well, what if I did a different setup, maybe AC sine of the angle between them, and that's B. Or maybe I do 1/2 and BC times the sine of angle A. Okay, a little bit off screen. I got some shadowing going on. I'm sorry about that. All right, so the area of the same triangle should be equal to itself, shouldn't it? Okay, so I'm going to do some algebraic magical wizardry here. I'm going to multiply all three sides by 2. Okay, and the reason is I'm developing a formula. So AB sine of C equals AC sine of B equals BC sine of A. Again, this is all just laying down background. Okay, and now I'm going to divide all of these by A, B, and C. And just a reminder that while I'm writing this, the lowercase are the side lengths, uppercase are the angles, and they're always opposite each other. Okay, so this is a convention that most people use. Angle C is across from side C. Angle B is across from side B. Angle, and that's, we're assuming that layout of information. All right, so back to where we were as we were already in progress. The A's and the B's cancel out. The A's and the C's cancel out. The B's and the C's cancel out. So what I'm left with is sine C over C. I'm left with sine B over B. I'm just writing them in this way because this is the way most people see this because it's the last step. Sine A over A. And what we just, sorry, let me scooch up. What we just established was this rule. And remember, this is, okay, it's based on area, but now it's not about area anymore. Now it's just about angles and side lengths. This is called the law of sines. Okay, so why the law of sines? works with any triangle. Okay, so SOHCAHTOA, or the trig ratios, right triangle only. Pythagorean theorem, right triangle only. Okay, so hugely helpful, awesome, they're wonderful, very useful, but they only work for right triangles. Easier if you have a right triangle. Okay, and then one other quick note, this is the law of sines. Well, two other quick notes, sorry. Some people work with this upside down. So there is a property of proportions, since this is kind of an extended proportion, which would say if you flip, you can flip all three sides. The reciprocal, if you want the more mathy term, that works also, okay? And then, so both of these are considered the law of sines. Typically just work with this one, probably because it's been in more of the textbooks I've worked from. But if out of convenience you want to use this, you're very welcome to do that. You could switch between them all the time. Okay, one other thing is we never use all three ratios at the same time. We'll only use like just the A's or the B and the B's, or just the B's and the C's, or just the A's and the C's. Okay, so we don't use all of them at the same time. There's no way to solve for multiple variables, no convenient way that I'm aware of. Okay, all right, so all that said, that is the law of sines. Okay, we're gonna do an example. So the question becomes, how does this actually get used? Okay, law of sines, based on the kind of information that's in there, is only ever used to find, well, the problem will be something like solve the triangle, which hopefully you remember from geometry means find everything. So triangles have three sides, 3 angles, so that's 6 things altogether. You have to be given 3 things. If it's a right triangle, you could be given 2 things plus the knowledge that it's a right triangle, which angle is the right angle. But in this case, I need 3 pieces of information. Okay, this works for the geometric arrangements if I have 2 angles and a side, or 2 angles and a side, regardless of arrangement, or if I happen to have 2 sides and an angle not between them. Okay, so what I have here, I'm going to do a little sketch. This sketch is not drawn to scale. It's just a place to throw information. So again, A is across from A, B is across from B, C is across from C. Angle A, so 35 degrees. Angle B, 75 degrees. And side C is 12 centimeters. All right, cool. So worth noting that I have 2 angles and the side between them. This is technically ASA. Again, it doesn't really matter. If I have 2 angles and a side, law of sines works. All right, so again, our charge is to solve the triangle. Well, I know information about this C. The way the law of sines works is I have to have the same letters for each ratio. And if I'm going to work with C, I need C and C. Well, I have side C, I need angle C. So it turns out, because I have 2 of the angles, I can actually find angle C. Angles of a triangle add up to 180. So 35 plus 75, that's what, 110. So 180 minus 110 is 70. So angle C is 70 degrees. Okay, so I just found that. Okay. So now I can start using law of sines. So sine of 70 degrees over the side opposite it. So I just did the C over C. Okay. Now I need to find either side A or side B. It doesn't matter which one you find first or find next. That's not quite true. I'm going to recommend that you find either the biggest side the biggest first, if you can, or both smallest. This will be talked about more when we start getting into law of sines, the ambiguous case, when there are 2 triangles, or law of cosines. But right now, I'm just going to encourage you to find either the biggest side first, or the biggest angle first, or the both smallest. Now, how do you know? Well, the biggest angle and the biggest side are across from each other. As that angle opens up more, the side has to get longer. The smallest angle is across from the smallest side. Well, I already know the medium side. I don't know the biggest, so I'm going to find the other small one next. Okay, so this small one, so I'll have both small ones, so I'll have A and A. So I'm going to do the sine of A, 35, over side A, okay? And then we're just going to solve for A. Okay, so this is a proportion. I'm going to do the cross multiply thing. So 12 times sine of 35, sine of 70. And then I'm going to divide by the sine of 70. I am not a fan of typing everything in early, mainly because you have to watch for precision as you're going through, and you really don't want to use rounded numbers in the process. If I do type in the sine of 70 early, and then I use a rounded number, that's bad, you know, because then it throws off the next step. Okay, so I'm going to type this in. Worth noting, I'm in the degree mode. This is more geometry related, so not radians for this. Push mode, select degree, hit enter. Cool. All right, so next up, I'm going to type this in all at once. So I'm going to type in 12 times the sine of 35. Your calculator's starting parentheses here, you need to close them, divided by sine of 70. Okay, so I know I didn't type those parentheses, but I do have to be aware of them and close them. So 7.3246. So I'm a big fan of 3 decimal places. So I'm going to call that 325 centimeters, following the units that were given for side C. Okay, so worth noting that I'm writing this, but if I have to use this later, I will actually use that whole thing. I'm not going to use the rounded version of that to find anything. Okay, so we have found angle C was 70. We found side A is 7 point whatever. And I just need to find one more thing. Let me throw this on here. You don't have to throw it on the picture, but it helps me take attendance. In other words, I established that I know everything. All right, so I need side B. I'm going to go sine of 75 over B, so the B over B. And then I'm going to do A over A or C over C. Now, I'd rather not use that rounded one if I can use clean stuff. So I'm going to go back to, I know angle C is clean. There's no, by clean, I mean not rounded. So 70 and 12 is what I'm going to work with. So sine of C, 70, over C, 12. Okay, and now it becomes exactly like what we just did. So I'm going to cross multiply. Okay, I'm going to divide by sine of 70. So this looks very familiar, hopefully, and it should. Okay, so that's gone. Okay, and I'm going to do some typage. Now, if you're feeling a little fancy, worth noting, so this said 12 sine of 35 over sine of 70. This says 12 sine of 75 over sine of 70. It's the same stuff, except that 75 instead of 35. So I'm going to go up arrow and hit enter. Now, if you're working with a TI-83, you could do second and enter, which does entry, grabs the last thing. And you can go in and edit. Well, I want that angle to be 75. So literally, I'm just going to type 7 there. Boom, chakalaka, we're done. So 12.33500. I'm going to call that 12.33. I'm off screen. Sorry. 5 centimeters. Okay. All right, so this is done. Worth noting, I have a side A and an angle A. Okay, I'm going to have to slide around to make this happen. So I have both of my A's. I have B, and side B is way down here. Here it is. Okay, and I have side C and angle C. Cool. So I just, at the end, I like to take attendance so I know I have everything. Should have 3 angles and 3 sides when you get done. Okay. All right. So one possibility is starting with 2 angles and a side. And the other possibility is starting with 2 sides at an angle. So we're going to do one more example. Okay. I know this is already feeling a tad long, but maybe another 5 more minutes, maybe 7 more minutes. We'll see. So, burning daylight here. Stuff ready. I should have had it. Yeah. All right. So we're starting with 2 sides and an angle. If I do a little sketch here, okay, and all I'm doing is slapping A, B, and C on here. I'm not worrying about scale, not drawn to scale at all. So angle C is 85 degrees. Side C is 15. inches this time, and side B is 12 inches. Okay, so just to try and pick up what's going on here, the sides I know are this side and this side. The angle I know is over here. So it is not between those two sides. It's not made by those two sides. This is a side-side angle arrangement of information. Now, that side-side angle should be, causing a little stir in your head, a little back of your neck hairs going up. In geometry, that we were not allowed to prove triangles congruent by side-side angle, and there's a reason for that. There is a potential that there are two triangles possible. We are not going to deal with that issue in this video. There's a separate video for that, 55B, and you can see that for all those details. Right now, all we're going to do is worry about solving. Okay, so what I have a C and a C. I have a B, maybe I can get a B. Okay, all right, so here we go. I'm going to do sine of angle C over side C equals sine of angle B over side B. Now, I don't need to really cross multiply here because the variable that I'm solving for is on top, so I'm just going to multiply by 12. You can cross multiply. You'll end up doing an extra step. Okay, so sine of B equals, all right, I'm back to the calculator again, still in degree mode. Okay, so 12 sine of 85 divided by 15 this time, so not the sine of 15, just 15, 0.796. Now, you might be saying to yourself, that's a dumb number for an angle, unless we're in radians or something like that. But worth noting that that's not the angle. That is the sine of the angle. Okay, this still says sine. So to make that sine go away, we're going to do the inverse sine of both sides. So inverse sine, okay? And so now I'm just going to type in inverse sine of that number. Okay, so I'm very grateful for the calculator being set up the way it is. I can do inverse sine. Now, if you're on an 83 or older, you can do second answer, second negative, right above that. It does answer. On the 84 newer systems, you can just use the up arrow and copy it by hitting enter. And there we go, 52 point something. So angle B is 52.840, and that's degrees. Okay, so I'm going 3 decimal places for that. Okay. All right, so that's angle B, 52.840. Now, the issue is, what do we find next? Okay, well, I have angle inside B, I have angle inside C, so I need to find some A's. That's what I'm hoping to find on my report card. The issue is I can't use Pythagorean theorem because it's not a right triangle, so I can't do a squared plus b squared equals c squared. That just doesn't work. The only other thing I can do is I can do law of sines again if I knew angle A. Well, I can get angle A because angles again add up to 180 in a triangle. So if I do 180 minus the 52 point whatever this is plus 85, so 180 minus whatever that is. All right, so I'm going to start working with this. So I'm going to take that angle plus the 85. So that's 137. Okay, so 180 minus that guy. So 42. So this is now angle A is 42.1596. So please note, I did not use the rounded version. Well, I'm technically the calculator's rounding, but I used as much as I possibly could. Again, I'm worried about precision. I don't want, if I do a rounded and then round the next thing off of that and round the next thing off of that, I have made, by the time we're done, errors that you'll see. Okay, so last thing to find is side A. So I know angle A, 0.160 over side A equals sine of, now I need any that I know both of. Okay, so I know both C's and both of those are clean, so I'm going to use that. So sine of 85 over side C is 15. All right, so I'm going to do some cross multiplying here. So 15 sine of 42 equals A times sine of 85. Okay, and I know I'm moving along. I mean, you are welcome to pause, stop, replay me as much as you wish. I'm just trying to, for those people who are keeping up, trying to keep it moving. All right, so 15 sine of 42 point whatever. I'm going to use my up arrow. Ooh, look at that. It was just the next one up. Sweet. Close parentheses. Don't forget to close parentheses. Over sine of 85. Don't really need to close them on the last one, but I do anyway, just because. All right, so little a is 10.106, and I believe this was in inches. All right, so what do I have? I had B, and I found B. I had C and C, and I have A and A. Okay, so that's everything. All right, so just a quick little recap. The law of sines is this, or it's flip. You know, you can flip all three of these if you wish. A's with A's, B's with B's, so it's fairly easy to remember. It only works when you have, or you're only ever going to use two ratios at a time, and you need to have three of these four things, or three of these four things. So if you're setting it up and you don't have the right stuff, then maybe it's going to be law of cosines, which is in the 5-6 video. So the idea here is this is for solving triangles with this kind of information. If you have side-side angle, there is a possibility of two triangles, again, handled in another video. All right, well, that was our installment of SanfordFlipMath, the home edition. Thanks for hanging with me, and we'll see you later. Bye.